In this video, remember in the last video we saw that if the second derivative turned out to be 0, you could have either a relative maximum or a relative minimum or neither one. In this video, what we're going to do is let's take a look at another way of determining whether a critical point locates a relative maximum or relative minimum or neither one. All right, and so let's start with this idea. This is called the first derivative test. Suppose that f is continuous at a critical point x0. If f prime of x is greater than 0 on an open interval extending left from x0, and f prime is negative on an open interval extending right from x0, then f has a relative maximum. All right, think about it this way. If it changed from positive to negative, we change from increasing to decreasing. So if we're going up and then coming back down, we must have a maximum in between. If it changes the other way from negative to positive, then we're decreasing and increasing, so we have a relative minimum. And if it stays the same on both sides, positive on the left, positive on the right, or negative on the left and negative on the right, then we have neither a relative, there's not a relative extremum there. So let's take a look at an example of this. All right, so again, here's the idea is that if we have f is continuous, if we change from a positive derivative, first derivative, to a negative first derivative, it must be a maximum at x0. If we change from a negative derivative to a positive derivative, there must be a relative minimum. Okay, let's take a look at this function. F of x is equal to negative 3x to the fourth plus 16x to the third minus 24x squared. So let's start by looking for critical points, and we'll need to look at the derivative. And so we'll have negative 12x to the third, plus 16, 48 x squared, okay, all right, minus 48 x. And now I think I can take, to factor this, I think I can take a negative 12x out of every term. So if I do that, negative 12x, I'll have left here a positive x squared minus 4x plus 4. Okay, and this factors as follows. Negative 12x, and then this is x minus 2, the quantity squared, I believe. X squared, x minus 2, the quantity squared. So setting that equal to 0, I have that either x is equal to 0 or x is equal to 2. Right. Now these are places where the first derivative is 0, so I could apply the first or second derivative test to whichever I prefer. All right, but let's take a look at this. Let's take a look at this where let's apply the first derivative test. If I think about it this way, all right, we have the first derivative being 0 at 0. We have the first derivative being 0 at 2. And so let's imagine what happens on each side of these. All right, this is the only place the first derivative is 0. These are the only places it can change sign. So let's take a look. Here's the first derivative. All right, if I try a number less than 0, say x equals negative 1. Well, if I look at negative 12 times x, negative 12 times negative 1, that's positive. And if x is negative 1, I'll have negative 3 squared. That's also positive. That's 9. So the whole thing is positive. That means we have to be increasing here. Okay. Then if I look at this, say, between 0 and 2, say at x equals 1, if x is equal to 1, negative 12 times 1 is negative. All right. And then negative 1, positive 1 in for x, here I have 1 minus 2, negative 1 squared. Negative 1 squared is 1. That's positive. So the whole thing is going to be negative. So we must be decreasing here. So right in here, there must be a relative maximum. We change from increasing to decreasing. All right, that's out here to the right of 2, say at x equals 3. Well, negative 12 times 3 is negative 36. That's negative. And 3 minus 2 is 1. 3 minus 2 is 1. 1 squared is 1. That's positive. So I have this first derivative is negative out here. So notice we're decreasing again. So we have neither a relative max or a relative min. We decrease as we get to 2 from the left, and then after we leave 2 on the right, we decrease again. So there's nothing here. Neither a relative max or a relative min. It's not a relative extremum. All right, and so what we have to do, I think I have these listed here for us, because I'm worried I'd make a mistake here. So notice that that at these places, well, we found out that we were increasing here. So we had a relative max, and I didn't put the value on the relative max, but at 0, the relative maximum would be the function value, so 0, and the relative minimum, well, it's not either relative max or relative minimum, but the function value would be negative 16 at 2. So what we have, and basically I guess I can say, is we have a relative maximum of f of 0 equals 0 at x equals 0. All right, and that's the only relative extreme value that we have. All right, notice how this looks. All right, there's a relative maximum top of a hill here at 0, and the height of that is 0. And then here at 2, we don't have either one because it's not the bottom of a valley or the top of a hill. So it's neither a relative maximum or relative minimum. The function was decreasing and then decreasing again. So that's one example of the first derivative tests.